So now this lesson is a very quick tidbit on the angle between two vectors using a scalar product. So if you were to talk about the correct angle that you want to determine between two vectors, you need to be very sure that we are talking about the angle in which either the both vectors are facing outwards, or are facing outwards. There's a tail to tail. We call this the tail to tail, right? Tail to tail simply because it's a tail of the vector to each other, or head to head, right? So simply because if you were to look at this head to head, this is the same as tail to tail. Like if you extend this, right? If you extend this, then the angle here is the same as the angle here. This will be tail to tail, right? Because of the vertically opposite angle. So it's either tail to tail or head to head. So what the misconception we cannot have to measure, we are not allowed, we do not measure angle this way, where this is head to tail or tail to head. Alright, simply the angle that we are measuring in this case, it has to be from, by the way, it has to be, we go outwards, extend, this is actually the angle that we are finding, the one in yellow. So it has to be tail to tail or head to head. Okay, so let's be very clear on this. Alright, we are looking at and if you notice, right, because it's always usually this angle usually is always obtuse or acute, right? It will never be more than 180 degrees because it's always cut up between the two straight lines. Alright, so your theta over here usually is always between 0 and 180 degrees. Right? Okay, so just take note that we do not look at our angle this way. Alright, it's always the angle between the two vectors. Alright, it's between 0 and 180. Number one is always tail to tail. This is not tail to head, is wrong. Alright, so remember, it has to be tail to tail, or head to head. This is how you measure the angle. Number two, the angle is between 0 and 180 degrees, so that's why this is illuminated. Okay. Alright. So, we will actually learn about scalar product later on, earlier on, and then we ask ourselves, like, what's the meaning of this scalar product? What does it really represent? So, scalar product, the dot product, actually, in the geometrical definition, is given by the magnitude of A multiplied with the magnitude of B, magnitude with the cosine of theta, where theta is the angle between two vectors A and B. When we talk about angles here, just remember, it's an acute or obtuse angle, and it's tail to tail or head to head. Alright, so next, how do we if knowing this, right, like why is it true? Is it possible that we can do a proof of this? So let's do a very quick proof of this. The proof of this formula actually comes from the cosine rule. So the cosine rule is something that we have learned earlier on. Okay, remember, like, if we have for example, this is the length A, this is the length B. Length are not vectors, okay? Alright, then this is the length C. Then C square equals to A square plus B square minus 2AB cosine theta, where theta is the angle between side A and side B. Right? So we can actually do this for the vector form. It's just that for the vector form, how we look at this is we can look at it in a vector format. Right? Instead of A, we look at the vector A. So you look at vector A, right, in this direction, right? If in this direction, okay. Sorry. Okay, so for example, in this direction, not this direction, vector B in this direction, then we look at the vector, of course, there's no, we need to find the length of this triangle. We actually need to do find the magnitude. Okay, so this magnitude here, this will actually give us the length of this triangle. This will actually give us the length of one side, and this will give us the length of the other side. So what is this? Remember, this is vector A, this is vector B, right? So actually this can be written as vector B minus A or A minus B. Alright, so let's say it doesn't matter like everything. So let's say if I go from maybe this direction. Alright, so recall recall that let's say if you have A, correct, this is B, right, then what's this like? What would this be? This will just be B minus A, right? So with that, the next thing you to do is let's just try to erase this first. Right, so the next thing you want to do is to prove this. So B minus A, so we can call this as B minus A, and to find the magnitude, we can write it as the modulus of B minus A. So you can write from the original cosine formula C, this will become B minus A square. Okay, right, this is C, B minus A. A will be modulus of A square, B, modulus of B vector B square, minus A, magnitude of A, magnitude of B, cosine theta. Okay, so as we have studied in part 1, we know earlier on that the magnitude of A squared, this is just the square of its own scalar product upon itself. So this, we can actually write it in this form. So this is B minus A dot product with B minus A, right? This will be the same as A dot A. Right, this is dot product of B dot B, right? This and this. How about this portion? This will be the same as 2 A modulus magnitude of A, magnitude of B, cosine theta. Alright, and for this, right, we can just expand this, right? So we can form earlier on, we can just expand. So this is expansion, distributive law. B and B, we get B and A minus B dot A and B minus A dot B, and it's the same as B dot A, right? It's the same as B dot A, right? So these two are the same. A and A, this is negative, so positive A dot A. Okay, okay, so with that, on the right hand side, let's continue write out everything as for the last line. B dot B minus 2A B cosine theta. Okay, with that, you can see that, can I cancel off anything? Yes, I can. B dot B, B dot B, A dot A, A dot A. Right, what do you see? You are left with negative, negative, negative. Right, so you can actually multiply both sides by negative 1. Okay, so you see I have two of them. Right, on the right hand side again, if I don't multiply, I have negative sign. Here, negative 2 A B cos theta. Right, if I divide both sides by negative 1, negative sign disappears. Right, if I divide both sides by 2, the 2 disappears. Alright, and we have our, finally we have our property we have showed later on, earlier on. Okay, so this is how we get the geometrical definition of the scalar product. Alright, so with that we have this definition. That's the cosine of theta, where theta is the angle between two vectors. You can also write it in this way, right? This is the same as the dot product of A and B over its own modulus. Okay, so let's look at example 2. So quickly, you can try example 2 on your own, and with that you can actually see the answer at the back. Okay, so but before that, do take some time, maybe take about just 10 minutes, quickly try this example on your own before you find the answer.